In this video, we're going to talk about imaginary numbers. The number system for us so far has looked like this. We have our real numbers, which is our big category, and then within that we have rational numbers and irrational numbers. Rational numbers are numbers that can be expressed as a fraction of two other numbers. Remember, even if a number doesn't look like a fraction, the idea here is that it can be turned into one. Irrational numbers are numbers that don't have this quality. So that's why we have numbers like pi, e, and the square root of 2. So within our rational numbers, we have our set of integers. Within our set of integers, we have our set of whole numbers, which is all the positive integers and 0. And then within the set of whole numbers, we have our natural numbers, which is just the positive integers. So what we're going to do now is expand this number system to include complex numbers. And then within our complex numbers, we have a set of imaginary numbers, which is what we're going to be talking about in today's video. So what an imaginary number does is it allows us to find the square root of a negative number. So remember, so far when you've been solving problems and you get to the point where you have the square root of a negative number, you've been writing no real solution. And the reason is because the solution is an imaginary number, and notice that imaginary numbers are not contained within the set of real numbers. So what we do is define I to be the imaginary unit, and what I equals is the square root of negative 1. So what we can do now is define other imaginary numbers using I and the product property, because if you think about it, you can actually factor the square root of negative 1 out of every other negative square root. So for example, if we have the square root of negative 4, we rewrite that as the square root of 4 times the square root of negative 1. The square root of negative 1 we already defined to be I, and then we just find the square root of 4, which is 2. So 2I is equal to the square root of negative 4. So let's rewrite the square root of negative 2 in terms of I. So the very first step will be to factor out that negative 1. So I have the square root of 2 times the square root of negative 1. The square root of negative 1 I can turn into I, so I have the square root of 2I. And then whenever we write these, whenever we have a radical, we usually just put the I in front of the radical. So this is going to be I times the square root of 2. So what we're going to do today is simplify the square roots of negative numbers. We're going to use the product property to factor out a negative 1 and then replace it with I. Then we'll simplify the remaining square root and then rearrange the terms when writing the final answer. So let's try simplifying these two expressions. So let's start off with A, which is the square root of negative 121. The first step is going to be to factor out that negative 1. So I have 121 times the square root of negative 1. The square root of negative 1 is I, and notice that 121 is a perfect square. The square root of 121 is 11, so I can just turn this into 11I. Now let's try B. So we have the square root of negative 900. So I can rewrite this as the square root of 900 times the square root of negative 1. The square root of negative 1 is I, and then 900 is also a perfect square. The square root of 900 is 30, so I can just rewrite this as 30I. So now let's try simplifying these expressions. So in A, we have the square root of negative 27. So this is going to become the square root of 27 times the square root of negative 1. The square root of negative 1 is I, and now the square root of 27 is not a perfect square. Remember back from our simplifying lesson, whenever we see a number that's not a perfect square, we need to think about how to make it better. So what's the biggest perfect square that will evenly divide 27? Well, the biggest perfect square is 9, so we have the square root of 9 times the square root of 3. Square root of 9 is 3, so we have 3 times the square root of 3, I. So remember, we usually write that I in front of the radicals, so I'm going to rearrange this as 3I times the square root of 3. Now let's try the square root of negative 125. So I'm going to first factor out that negative 1. So I have square root of 125, square root of negative 1. Square root of negative 1 is I, and let's think about how to make the square root of 125 better. Well, that's going to become the square root of 25 times the square root of 5. The square root of 25 is 5, so we have 5 square root of 5 and then I. So we're going to rearrange this and put that I in front of the radical, so we have 5I times the square root of 5. So now you can go ahead and pause the video and try doing this example on your own. So the square root of negative 18, remember the first step is we factor out that square root of negative 1, which turns into I. Then from 18, we can divide out 9, so the square root of 9 is 3, so we get 3I times the square root of 2. The square root of negative 200, we factor out that negative 1, so that square root of negative 1 becomes I. From 200, we factor out a 100. Square root of 100 is 10, so we get 10I times the square root of 2. So now let's simplify 10 times the square root of negative 20. So I'm going to leave the 10 in front, and then I'm going to work with that radical. So I have the square root of 20 times the square root of negative 1. Well, the square root of negative 1 is I, and then I still have that 10 in front, but let's think about how to make the square root of 20 better. The biggest perfect square that evenly divides 20 is 4, so I have the square root of 4 times the square root of 5. Well, I have 10 times the square root of 4 is 2, and then I have the square root of 5, and I have I. 10 times 2 is 20, so I have 20 square root of 5, I, and then I can rearrange this and write it as 20I times the square root of 5. So what we can do now is we can also simplify powers of I, and we can do this using the properties of exponents. So for example, we know that since I equals the square root of negative 1, I squared equals negative 1. Because what we can do here is we can square both sides of this equation, so we have square root of negative 1 squared, and then that squared and the square root cancel each other out, so we get I squared equals negative 1. We can also now solve equations like x squared equals negative 1. Right? If we have x squared equals negative 1, we can actually take the square root of both sides. And so that's going to give us x equals plus or minus the square root of negative 1. Well, we know the square root of negative 1 is I, so we have x equals plus or minus I. So what we can do now is list out in this table the powers of I. So for example, if we have I, well, that's just like I to the 1, so that's just equal to I, right? Now we can do I squared. Remember we said that I squared is going to be the square root of negative 1 squared, which equals negative 1. So that's going to equal negative 1. Now we can do I cubed. Remember, using our properties of exponents, we can write I cubed as I times I squared. Well, I times I squared is just going to be I times I squared, which is negative 1. So that's going to be negative I. Okay, so I cubed equals negative I. Now let's try I to the 4th. Using our exponent properties, I can rewrite I to the 4th as I squared squared. I squared is equal to negative 1. Negative 1 squared, well, that's just equal to negative 1 times negative 1, which equals positive 1. Now let's try I to the 5th. I to the 5th is going to be I cubed times I squared. Well, we already found I cubed, that's negative I, and then I squared, we already said was negative 1. Negative I times negative 1 equals positive I, so I to the 5th equals positive I. Now let's try I to the 6th. I to the 6th, there's several ways we can rewrite it. I'm going to write it as I to the 4th times I squared. Well, we already found I to the 4th, that's 1, and then we know I squared, that's negative 1. So 1 times negative 1 equals negative 1. Now let's try I to the 7th. I to the 7th I'm going to rewrite as I to the 4th times I cubed. I to the 4th is equal to 1, and then I cubed is negative I. So 1 times negative I equals negative I. And now finally let's do I to the 8th. I'm going to rewrite that as I to the 4th squared. So I to the 4th we said was 1, so we have 1 squared, which is equal to just 1. Okay, so notice in this table, these values start to repeat, right? We have I, negative 1, negative I, 1. And then notice it happens again. I, negative 1, negative I, 1. So this pattern that you see right here in these first 4 boxes will actually repeat for every power of I. So I just wanted to point this out. The most important power that we're going to be using a lot of is this I squared equals negative 1. But it's just good to know that the powers of I have this repeating pattern. So in summary, remember that imaginary numbers allow us to define the square roots of negative numbers. The imaginary unit is I, and every other imaginary number is a multiple of I.